In this video, we will cover both rip tools, that is rip region and rip edge. The rip region tool gives us the power to create gaps in a mesh by dragging on vertices or edges. It is not possible to use this tool on complete faces. To use the tool, we must start by selecting the vertices or edges that we want to separate from surrounding elements. When the rip region tool is selected, a yellow-filled circle will appear at the center of the selected elements. As we drag within the circle, the selected elements move away from its neighbors. The part of the circle in which we start the drag operation determines which face is pulled away, as we can see here. To create the effect, Blender automatically creates any new vertices, edges, and faces that may be required. We can see this in the statistics values where the number of vertices, edges, and faces increase as we perform the rip operation. This is an easy way to open a cube to give the effect of a lid. When we use the Rip Region tool, we create a hole in the mesh. However, if we want to avoid the hole, we can select the Fill checkbox that appears in the top left of the 3D viewport before we perform the rip operation. As with most operations, using the Rip Region tool creates a last op panel. The Move X, Y, and Z fields specify how far the selected elements are moved along each axis from their original position. Strangely, although there is no Fill field in the last op panel, adjusting any of the distances automatically creates a fill effect, eliminating the hole in the mesh. This is in the March 2025 version of Blender 4.5 and is possibly a bug. The Orientation field specifies which set of axes the previous three fields refer to. During the drag process, the top left corner of the 3D viewport displays the distance traveled in each direction. There is a wide range of other options listed in the status bar once we start the rip operation. You've seen all of these before if you've watched the earlier videos. Pressing X, Y, or Z while dragging restricts movement to that direction. The axes set to which these directions refer depends on the current setting in the Transform Orientation panel. Press Shift and a direction letter, and movement will be on the plane defined by the other two letters. Hence, pressing Shift-Z will restrict movement to the XY plane. The C option only appears on the status bar if we are using one of the two previous options to restrict the movement direction. In this situation, pressing C cancels those restrictions, allowing free movement. B refers to selecting the part to be snapped when using snapping. This can be a little tricky to use for the first time. We need to employ the following sequence. Select at least one edge for ripping. Start dragging and then press the B key. Do not release the left mouse button. The moved elements will jump back to their original position. With the left mouse still pressed down, move along the selected edge. You'll see the various shapes used to identify parts of the edge. That is a square when the pointer is over a selected vertex, an hourglass shape when over any part of the selected edge, and a triangle if over the center of the selected edge. When at the part to be snapped, release the left mouse button and move the mouse pointer over the area to be snapped to. You'll see the same symbols as before as you move the pointer about. Click the left mouse button and the two selected parts will be snapped together. Hold down Ctrl to invert the current snapping state only while that key is held down. Since snapping is normally off, this will switch it on. The snapping characteristic is determined by the current setting in the snapping panel. By default, this is set to Increment, so dragging with Ctrl held down is most likely to cause the positioning of the rip elements to reposition in incremental steps. Shift tab also inverts the snapping setting, but this time the change is permanent, even after the rip operation is complete. Pressing G during the drag will force the ripped elements to move along existing edges. Pressing R rotates any selected edges. Further dragging of the mouse adjusts the rotation angle. Pressing S adjusts the size of selected edges. Pressing down the middle mouse button as we drag has a similar effect to pressing a direction letter. However, here the direction is selected by the broken line shown beside the highlighted axes. The axis that line is nearest to becomes the direction in which movement occurs. Holding down Shift, as well as the middle mouse button, restricts movement to the plane that excludes the direction nearest to the broken line. Holding down Shift as we drag gives us greater control of the placement by being less sensitive to mouse movement. The keyboard shortcut for the rip region operation is the V key. As usual with shortcuts, no gizmo is displayed, and the mouse should be moved with none of its keys pressed. Press the left mouse button or the Enter key to complete the operation, or the right mouse button or the Escape key to cancel it. Moving on to the Rip Edge tool, this is more like a form of extrusion. With it, other existing faces extended to stay connected to the elements being moved. Perhaps there are occasions when we might want to use this option on 2D surfaces, but used on a 3D shape, it has a tendency to create non-planar faces. The top left corner of the 3D viewport shows the distance moved, and the status bar has the same options as we saw with the Rip Region tool. The keyboard shortcut for this tool is Alt-D.